And the way that this works is each decorator decorates what's below it. So, change default is decorating very decorated. Return type is decorating change default. And finally, add attributes is decorating return type. Welcome back to Understanding Python. My name is Jake, and today I'll be talking about decorators. Decorators are a powerful tool that allows you to modify the characteristics or behavior of a function. Understanding and mastering decorators unlocks a new world of function design and will put you further down the path of becoming an advanced Python programmer. So let's jump right in. So at the top here you can see I put a little bit more into the docstring than usual. That's because decorators can seem intimidating at first, but if you've been following this series, you've met all the prerequisites to follow along. If not, then at a minimum, go watch my video on functions and come back. So the basics of decorators are that they are functions that accept other functions as an argument, and from there they can either modify the original function or completely replace them. Now I like to consider decorators as falling into 4 basic patterns. The first pattern is a decorator that returns the original function. And the way we do this is we make a new function called change default. This is going to accept a function as an argument, its only argument, and at the end it's going to return the function. Now that's not very exciting, so let's add a little bit more behavior in here. And in order to determine what kind of behavior we want to add, let's look at functions in IPython. So we'll make a simple function here called TestFunc that has an argument a with a default value of 5. And all it's going to do is return a. Okay, so we have this TestFunc object. And one thing we can do to look at this is we can call the directory method on this test function. And let's give ourselves a bit of room so we can look at this. We see there are a number of dunder attributes in this function. The one that we're interested today is called defaults. So let's look at this defaults. TestFunc dot dunder defaults. And we see we have a tuple with the value 5 in it. And that corresponds to a equals 5. So the default value for a is shown in this defaults here. So what if what our decorator does is it modifies the value of that default? Well, we can simply do this. We have the function object. So just like we did in IPython, we can access its defaults attribute and set that equal to a new tuple. And instead of saying 5, we'll have changed. We'll add a quick docstring. And the docstring explaining the decorator says this decorator changes the default value of a single argument function. So now let's recreate our test function in code. Okay, now we have our test function. So let's call it in a new print statement. We'll save it and run it. And now we see down here, calling TestFunc, and it gives us the value 5. Perfect, so TestFunc is working exactly as expected. That's because we haven't applied the decorator yet. Now, if Python didn't have a really nice decorator syntax, the way that we would apply this decorator to TestFunc would be to use this notation. TestFunc is equal to change default, and we're going to pass in TestFunc. So what happens here is we're overriding test function with the output of change default. And of course, change default accepts a function to which we're passing in TestFunc. And as change default goes through, we hit its second line where it changes the default value to changed and then simply returns the function. Now, of course, this works perfectly fine. So if you save and run this, we'll see calling TestFunc. And now the new value it prints out is changed. But this on line 16 is pretty ugly. Luckily, Python has a better syntax for this. So we'll get rid of that version And instead, we're going to use the @ symbol, change default, right at the top here, right above the function that we want to decorate. So now if we save and run it again, we'll see we have the exact same output, calling TestFunc, and it prints out the value changed. And now you know how to make a basic decorator, or decorator that meets pattern 1. In preparation for pattern 2, I added oldFunc in here, which simply returns a string that says, I'm an old function that shouldn't be used. This would simulate a function that you don't want anyone else to use anymore. And the way we can convey this point is that we can use the second pattern, which is a decorator that returns a new function. So we'll call this decorator Deprecate. Of course, it takes a function, and we know that it's going to return a new function, which we can define within the scope of Deprecate. So we'll just call this new function nothing. Since we want this to be pretty general, instead of being specific to oldFunc, we're going to have it accept *args and ** keyword args. If you remember back to my video on functions, you know just how flexible this pattern is. Now what function nothing is going to do is simply print an f string that has func.dunderName, which is the actual name of the function that's being passed in, which we saw when we used the dir method on our function earlier. And we could have put a message after saying has been deprecated. Now here we can either return a particular value or just nothing. And since we don't really want to return anything, we can just get rid of return altogether, moving out to the level of deprecate. And what deprecate is going to return is the function nothing. So let's call this how it is right now. We'll save it and run it. And we say, calling oldFunc, I'm an old function that shouldn't be used. Now if we use the deprecate decorator, save it and run it, we see oldFunc has been deprecated, and also the message calling oldFunc none. So what's happening here? Well, instead of actually running oldFunc down here in our print statement, we're really running nothing, because the deprecate decorator actually switched the two functions out. So this old function is never actually ran anymore. And now you're starting to see the power of decorators, is that you can take in a function and do just about anything you want with it, including not running the function at all, or swapping out for an entire function altogether. So I'll add a quick little docstring to deprecate. And that docstring being, this decorator stops a function from running and prints a message. I did a little bit more prep for pattern 3, which we just added a really basic function which simply returns, as well as the print statement associated with it. Now pattern 3 is where we can really add in a lot of customization and make our decorators pretty flexible. That's because pattern 3 is a decorator that accepts arguments and returns the original function. In order to do this, we'll make a new function called addAttributes, which is going to take in ** attributes. We'll call it attributes in this case instead of keyword args, because it's a bit more clear what it actually is. Now you may be asking yourself, why didn't it accept a function? That's because this pattern is a bit different than what you saw in the previous two patterns. What's actually going to accept the function is the function we're going to write under the scope of addAttributes, and we'll call this decorator, because this is what's going to do the actual traditional decorating work, and this is what accepts the function. So within this decorator, we're going to iterate over the key value pairs in attributes.items. And for each of those, we're going to use the built-in function SetAdder, passing in the function that our decorator receives, and then the key and value. This is what's going to add each attribute to our function. Then our decorator is going to return the function, and addAttributes is going to return the decorator. Then the way that we apply this is using add attributes. And since it accepts keyword arguments, we're going to toss in something, give it the value of else, throw in another, and set that equal to true. And to demonstrate, we actually add 2 more print statements, and we'll change this to basic func dot notation. And here, put something down here, else, and then use the dot notation on basic func to access those values. And of course, else should actually be another. Let's save it, run it, make sure that it works, and we see that it does. The last 3 lines, calling basic func, returns none, as expected, because we didn't change any of the behavior of basic func. Instead, we added the attributes something with a value of else and another with the value of true. But how exactly is this working? Let's quickly show the longer notation and see if that helps. So we're overriding basic func with the result of calling add attributes with something and another passed in, and that is returning the decorator, which we're passing in basic func. So add attributes is returning another function, which then we're calling that function with an argument of basic func, and get the end result, which is basic func with a couple more attributes added, and then pass that back along to the original basic func. I hope that clears that up. Understanding this part of decorator syntax isn't the most intuitive, so if you have any questions about this or need additional clarification, let me know down in the comments and I'll be more than happy to assist. So add a helpful doc string to add attributes. This decorator adds specified attributes to a function. In preparation for pattern 4, I added a new function called loseReturn, which simply returns any object that's passed into it and tells you the type of the object that's passed in. And then for our print examples, we're passing in both a string and an integer. So we'll save that, print it, and see what that looks like. And we see that loseReturn says I'm returning an object of type string because we passed it in with a string, that string being test. Then next, I'm returning an object of type class int because we passed in an integer 15. Now, if we wanted to make sure that our functions aren't returning different values and we wanted to stay away from type notation, we can make a decorator using the 4th pattern, which is a decorator that accepts arguments and returns a new function. So our outer function is going to be called return type, and that's going to accept an argument called ret type, standing for return type. Then we're going to write our decorator, which accepts the function, and then a new function here, which we're going to be swapping out for loseReturn, called runner. You could also call this wrapper or something else. It doesn't really matter too much as this won't be presented to the user, which accepts star args and star star keyword args. And what runner's going to do is it's actually going to run the original function, passing in those args and keyword args and storing the result. So result is equal to func unpack the args, unpack the keyword args, and now we can assert that what we get back as result is the same instance as a return type that the decorator accepts. So we'll use the isInstance built in, checking that result is an instance of ret type. And then finally, we'll return the original result that we got from the function. So runner's returning result, the decorator function is returning runner, and then the return type function is returning decorator. And to apply this, we'll use @return type, and then we'll pass in the type string. So anytime loseReturn is called, if it's returning a string, perfectly fine. If it returns anything else, then it's going to give us an assertion error. So we'll save it and run it. Oh, and there we go. If we look at the last few lines, we see I'm returning an object of type string, calling loose return with our string test. Then it says I'm returning an object of type class int, and then we get the assertion error. And we see that assert is instance, result, and return type was not true. So in this way, we're explicitly checking to make sure that loose return is returning a string and nothing else. And you can swap this, of course, out for an integer if you want. Save it and run that. And you see, you get the same error. Now, final thing before we go is that you can apply multiple decorators to a single function. So if we wanted to add change default to this, we can. If we wanted to also add in return type, put in that it should return a string, because if you remember, change default changes that default argument to a string, we can do that as well. And we can also add attributes to this. Again, we'll add the attribute something with the value of else. We'll just add one additional print statement down here just to prove that something did apply. And before we save and run, we'll comment out this line up here so we don't get our assertion error. Now if we see the last two lines, we see calling very decorated now has a default value of changed, and very decorated.something is equal to else. And the way that this works is each decorator decorates what's below it. So change default is decorating very decorated. Return type is decorating change default. And finally, add attributes is decorating return type. So you can think as the top as being the outermost layer, with the bottom being the innermost layer. And that wraps up this video. Now that you understand decorators, experiment with them in your code base and see what you can come up with. What is your favorite trick with decorators? Or was it something I showed today? Leave a comment down below to let me know. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with this series, please consider subscribing. Thanks for watching.